the following. Things like what is cloud computing? What is the cloud and where is it? The three cloud deployment models, differences between cloud service types, core cloud services, and the benefits of enterprise IT moving to the cloud. So, what exactly is cloud computing? Cloud computing is the delivery of resources needed to host and build and run software securely over the internet instead of building it on site at an organization's private data center, which is traditionally how applications are deployed. The appeal of cloud computing to development teams is that it provides faster innovation, more flexibility, and many other pluses, and it provides these all at a lower operating cost. So, in the cloud, offerings in the cloud, such as servers, virtual machines, databases, etc., are referred to as services, as cloud services. One major advantage is that in terms of costs, cloud usage is based on what we call the consumption model, and you only pay for what you use, which is a lot different than traditional apps development and deployment. Um, so, where is the cloud? Um, Many times, I'm talking to somebody that's a non-technical person, and they'll say something like, I hear people talking all the time about things being in the cloud or their stuff being out in the cloud. Okay, well, where exactly is the cloud? They always want to know that. So the Azure cloud is made up of data centers that are located around the world, and they're connected by a latency network. And by low latency, I just mean that it's simply that it's a very fast network with almost no lag time. So you choose the features and the power of those features that you want to create um, and put in the cloud. And the data centers house the things that you create. So essentially, when you're creating an application behind the scenes, you are using the physical resources of one or more Azure data centers. So these global data centers are organized by geographies and regions inside of those geographies. The geographies are usually countries, and there are several regions inside of each geography. So, for example, on the slide, I'm going to use the United States as an example. So the geography is the United States, and there's several regions inside of that geography. For example, on the slide, I used US West and US East 2. And in each of those regions, there are several data centers. Um, so, what I wanted to do to help you further visualize this and conceptualize this, I wanted to look at the Azure Network Live. So, here is the network live. You can see that all of these geographies and regions are connected around the world. They're connected by 175,000 miles of fiber optic and undersea cable network and systems. And they hit about 140 countries. Um, and Azure has more regions than any other cloud provider. So let me go to the United States, for example. Here is the geography, the United States. Each of these light blue dots are regions. There's US West, there's US East 2, and you can click on these and it will show you where the regions are and tell you a little bit more about the regions and their zones, etc. You could also, and we won't do this right now, but you can also go here and take a virtual tour of a data center to see exactly how the data center, what it looks like, how it operates. They get kind of technical. It's kind of cool. So that is what the the cloud looks like live. And that was just to give you a visual to be able to comprehend it easier. So getting back to regions, regions are important. And they're important because they allow developers to deploy applications closer to their users, regardless of where the development team is or where those users are located physically. Regions also allow for the adoption of residency standards. And by that, I mean that different um, regions and geographies have different laws about data and data privacy. For example, the EU may have certain laws and standards that are completely different than the US. So the regions give you the ability to deploy applications where they are needed, where you need to deploy them. Um, Regions also provide better scalability and redundancy. And we're going to talk about those things a little later. So now we've kind of covered the basic cloud architecture. Um, let's talk about the different types of clouds. So on the left, you have the public cloud, and this is the model that is most referenced when discussing cloud technology. Um, Azure services, on the Azure public cloud, the services are exposed to the public, and anyone on the internet can access them. An example of public cloud providers is Microsoft Azure, of course, Google Cloud, and Amazon Web Services. So to the right, to the far right of the slide, there's also the private cloud. And the private cloud is used by a single organization on a private internal network. It's not exposed to the public. It resides inside of the organization's firewall, and only people in that organization have access to it. And it also requires the traditional staffing that would be required for traditional deployment. Some people use a private cloud for security reasons, or if for some reason it's dictated by law with whatever type of data they're handling. And then in the middle, you have the hybrid cloud. It's a combination of both public and private clouds. Um, and this is a situation that some people use to keep sensitive um, applications or data inside of their private cloud, whereas um, they can have other services that are hosted on outside of the organization on the public cloud. Another reason somebody might do this, a company might do this, is because they can use the hybrid cloud model to slowly migrate to the public cloud. They don't have to do it, the migration all at once. So we're going to talk about cloud service types. There are three: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service refers to hardware, storage, compute power, network services. It's the layer that runs the application, makes the deployment, the running of the application possible. Examples include virtual machines, servers, storage accounts. Platform as a service, it's the layer that sits between infrastructure and software, and it is managed by the cloud provider, and it provides developers with tools to build their applications. So an example of that would be the Visual Studio IDE, or something like the SQL Server managed instances. Software as a service um, allows users to consume an application completely as a service. The cloud provider is the sole responsibility, has the sole responsibility for its management. And examples of that are something that most of you use every day: Microsoft Office 365 and Microsoft Outlook. So, an important concept when deploying in Azure is the concept of shared responsibility. And the type of service that you deploy in Azure dictates your level of management responsibility versus the cloud provider's level of management responsibility. So you can see on the far left side, this is what on-premises traditional deployment looks like. You or your development team or your administrative team is responsible for everything, for the infrastructure, for the operating system, absolutely everything. So next over is infrastructure as a service. And an example of this would be if you deployed a virtual machine in Azure. At that point, Microsoft Azure would be responsible for managing that infrastructure, that virtual machine, but you would be responsible for managing the operating system, middleware, runtime, applications that you're going to build, data, etc. The next over is platform as a service, and this time you can see that Azure is responsible for managing a little bit more. Um, so if I was going to migrate a SQL server onto Azure, for example, and I chose SQL Server Managed Instances, it's right there in the name. Um, Microsoft Azure manages everything about that SQL server that I would normally have to manage on premises. And then all I'm responsible for is the databases and the data that I bring over and the applications that I build using that service. And finally, you can see that software as a service, you're just going to be using that piece of software. And Microsoft Azure manages absolutely everything for you. You don't really have to do anything but, get on to um, Microsoft Word or Excel and use it however you plan to use it. So we have talked about cloud service types, and now I'm just going to touch on core cloud services. And they're called core cloud services because these are available in every region of Azure. There are certain services that are not available in every region. And this is not an exhaustive list of the core services. These are just these are the ones that enable app development and that people who are beginning to learn about Azure should know about and look at first, I think. So you have compute services, um, which involves running your applications. Um, for example, you got virtual machines, you have Azure App Service, you have storage that includes blob service. And blob service, for example, is a starting point for many projects. Blob service includes data lake generation to storage. That's important because data lake can store any type of data. It can store structured or unstructured data. And it is also compatible for use with big data clusters and data analytics. So you also have databases, networking, identity management. Those are kind of self-explanatory. Um, in the middle, I have content delivery networks. Um, and what that is, it's a network that is used to deploy applications that I guess, for example, if you want to think about CDNs, you would think about a streaming platform like Netflix. This network deploys large files and any kind of streaming content from a central server out to what are called CDN nodes, and from there, these nodes push out a cache version, excuse me, of files out to what are called edge servers. So then, when somebody clicks on content in Netflix, for example, um, they're going to get content from these edge servers, and it makes them it delivers it closest to where that user is. So it optimizes streaming performance, and it makes the latency really low and really fast. So if you want to look at the different services, you can go to Azure, Microsoft.com. And there are tons of information about each one of these services, the core services, what services are free, etc. So now we're going to talk about the advantages of cloud computing. But first, before we do that, we need to compare traditional deployment to cloud deployment. So traditional deployment on the left, that is when you're deploying into an on-premises data center owned by an organization. It's very slow, it's tedious, and it takes a lot of time and a lot of money. You're going to spend a lot of time, the staff, in other words, spend a lot of time planning and looking at a budget and trying to estimate what they need and how powerful the resources need to be, and also estimate what they're going to need over like the lifetime of those assets, like over 10 years' time. Um, so then they specify and order the hardware. Then they got to wait for the hardware to be delivered. Then they have to bring people in to rack and stack um, everything to build the data center. That involves deployment of hardware, configuration of hardware. Then they got to configure the operating system, any middleware, databases. Then they have to order the software, and when that arrives, that needs to be deployed and configured, and system settings need to be configured. And this might be a continuous process if and when they need to add something to the hardware as or reconfigure it as demand changes. So that could be a long, tedious process all over again. So now if you look at the right, on the right side of the slide, this is the process for cloud deployment. It's very fast by comparison because it is a platform as a service deployment, and it involves logging into your as the Azure portal through an account that is subscription based, and you dynamically create the sources that you need. It's also self-service provisioning. You build, configure, you deploy all of the resources that you need. There's no waiting for months or years. You can spin things up very quickly, and you can also uh, build things to automatically adjust to greater demand when you need them to do so. You can decommission resources quickly, and any of the changes that you make are seamless. You don't have to stop anything. You don't have to, the users don't have to know um, that anything's happening. So by now, you probably figured out that an advantage of deploying on Azure is the tremendous savings, and in terms of cost, and savings in terms of time that it takes to deploy an application. So the biggest cost savings is the shift from capital expenditure or CapEx to operational expenditure or OpEx. So in traditional applications deployment, CapEx is the focus is CapEx, and you're spending a lot of money and a lot of time on assets that have to last for years. You're spending a lot of money up front. The tax deductions on these assets can only be taken over time as the assets depreciate. Um, the financial focus in cloud deployment is on OpEx or operational expenses. And that's just simply the cost of running your applications in the Azure cloud. It's paid monthly or annually, depending on your service contract. And the deductions are taken that tax year. And your enterprise is only paying for the subscriptions and the utilization cost of deploying in the cloud. Um, Another plus of cloud deployment is that it takes advantage of economies of scale. Cloud computing gives the enterprise the ability to consume resources from pools of compute power, storage, and the resources that are offered by a provider. So, as a result, um, this results in the services being offered at a very cheap price. And again, we also have the consumption model concept. You're only paying for what you use, and you pay as you go. And Azure gives you the ability to halt certain processes when you're not using them so that you are not being charged for um, resources that you're not using. You also have tools like Azure Price Calculator and Azure Advisor. Those are portals that give you the ability to estimate cost and improve on savings. Another advantage of Azure is reliability um, by making the applications that you build highly available. And one way Azure does that is through local redundancy. So, an example of local redundancy is locally redundant storage. Say I have a storage account and I put a lot of things on my storage account. And so when my account is created, it is automatically replicated 3 times in one data center. It's automatic. It protects against server rack and disk failures in a data center. For example, a rack goes down, um, my data is still safe because I have 2 other copies, 2 other racks in the data center. Um, Another way that Azure provides high availability is through availability zones. So each region in Azure, within each region, there are multiple data centers. They're independently powered and they're connected by high speed network. These are referred to as availability zones, and there are at least 3 in each Azure region. They provide fault tolerance. And for example, if you were to build a virtual machine, for example, using these availability zones, Microsoft can offer you an SLA of 99.99% uptime for the whole year if you were to deploy your applications using 2 or more availability zones. This protects against data center failure and is highly recommended by Microsoft. There are also what is called paired regions. So each region in Azure is paired with another region in the same geography that is at least 300 miles away. And this makes for a regional pair. One of the regions is primary, the other region is secondary, And the paired regions allow for replication. They provide for protection from natural disasters, and they make disaster recovery very easy. So, for example, um, if I had uh, during hurricane season, a hurricane hit the East US region and took out um, um, a region, a lot of data centers in the East US. The application that I deployed is still going to be intact because it is paired with the West US region. So that is how that works. Um, Another benefit of Azure um, is agility and speed and flexibility. Excuse me. Um, Azure services can be provisioned on demand, and sometimes it only takes like a few minutes to provision a resource. It's very fast, and because of that, the build time in Azure is significantly less compared to a traditional on-premises deployment. Azure provides flexibility. Um, the Azure services allow for rapid provisioning and deprovisioning of resources. Um, any sort of modifications in Azure are seamless. And the big plus is that Azure manages a lot of things for you. So Azure takes care of time-consuming maintenance, freeing up developers and administrators, excuse me, to focus on their time on other tasks. Like I'm a DBA, for example. There are a lot of tasks that I do as part of database administration that are very time consuming. If I were to deploy on a SQL Server managed instance in Azure, a lot of that would be taken care of for me.
Hey, Robin,
Huh?
a quick question. Can you give an example of a service that you would provision so people can kind of relate what services we are provisioning?
Oh, okay. Yeah. So, um, an example of a service would that you would provision would be if you wanted to build a virtual machine in Azure. Virtual machines, say I am building an application and I provision a virtual machine. I provision some software to run on it. I deploy my application onto that virtual machine. I'd also need to provision, maybe I want it in a private network. I need to um, provision those sorts of network resources, or maybe I want it in like a subnet. Um, those sorts of resources are the things that I talk about when I say provisioning. Um, there's a lot of things, a lot of choices that you have in Azure, and it's not just Microsoft products. I could build a virtual machine and I could put a Linux operating system on it. Um, but anyway, to answer your question, those are just things that those are the things that I would build while I'm building my application. Does that answer the question?
Yes, ma'am. Thank you.
Okay. Okay. So now we're going to talk about scalability. And first, before we do that, we have to talk about elasticity. So, elasticity is the ability of a resource or process to expand or compress depending on the workload uh, demand, the demand of the workload that process is a part of. So, cloud scalability is the ability of a process or a network or software to grow and manage the increased demand of a workload. Um, in terms of scalability, you can scale up, meaning that when there's an increased workload, you can, for example, add additional resources like CPU or memory, for example, to a virtual machine. That's called scaling up in order to handle the workload. I could also scale out, which means that when the workload increases, instead of adding CPU and memory, I would be just adding more virtual machines so that I have a scale out. And then when the workload decreases, those virtual machines scale back down to one or two machines, whatever they were originally. The other advantage, big advantage of Azure is security. So, um, this first, we're going to compare DevOps to DevSecOps. In a traditional deployment, you build everything. There's development, there's IT operations, there's applications delivery. You build everything and then you go back and apply security. That's kind of the way it goes with traditional deployment. In Azure, however, we use what is called DevSecOps, and that means that the security is built into the objects from the get-go as they're being created. So that is a big plus. Azure also offers distributed denial of service protection, multi-factor authentication, and there's so many monitoring services like Azure Security Center, which is a portal for managing and monitoring the security of all of your resources. Azure also offers advanced threat protection, which identifies and mitigates security threats so that your application is safe from any type of hacker security threats. So, in conclusion, I have put together some resources here, Azure resources. You want to go to azuremicrosoft.com. There's a ton of information. There's a lot of documentation, white papers. Um, there's a cloud dictionary. The Getting Started section explains a lot of things about Azure and about getting started with Azure. There's a lot of free training. And I also want to emphasize to anyone that's interested in training on Azure, you can go to that bottom link where you can get a free Azure account and $200 credit towards your Azure subscription to get you started. And you also get access to certain free Azure services for up to 12 months.
Robin,
Yeah.
can you cut those things and put it on the chat?
I do have a PDF that we're
Okay.
going to send out that
Okay.
has those links so people
Okay.
can go
Awesome.
to them.
Awesome. Can I also, I'm waiting to see if any questions come up on the chat, but while we do that, can I kind of expound a little bit on an example for the dev security ops, that you explained, which for people who don't, let's just take ZettabytesToday, website, right? So our website both is run on WordPress, and it actually sits on Google Cloud. And DDoS errors, that distributed denial of service errors, this is something like somebody who wants to spam our website. So what they will do is they will set up a bot by which there'll be like 10,000 pings to our website, right? In like 1 second. So it just constantly hits our website. Of course, you don't see me. If I would put myself on video, you would see what a constant ping means this to our website. And in the previous world, right, when you had traditional, on-premises servers, that would be still hosted there, but it wouldn't have recognize there would be so much capacity, it would just let the database build up over time without crashing it. Here, the security is that it immediately detects that 10,000 pings to the website happen from one particular IP or multiple IPs, and it will basically shut down and stop any further spread of the situation. So that is a huge, for front-end developers, that's a huge, savior, if you will.
Exactly.
In some sense.
Yep. Exactly. Okay. Other questions or comments or?
You all can speak up or type it in your chat.
I got questions, Robin, if you're ready for me from yesterday.
Okay.
And if you don't, that's okay. We can connect offline though. I do think Dhruva raised her hand though, so I'm gonna let her go first.
All right.
Yeah, I was waiting because I had a mouthful of food when you said, "Do you have any questions?"
Oh.
So it's not really so much a question, like a comment. You were talking about, uh-oh, what happened to my video? Oh, so like you were talking about the flexibility, and then Rini was talking about the security.
Mm-hmm.
And I'll tell you, like I work at a company where there's like certain security standards that have to be met, and because of that, like one of the benefits is that it is flexible in its security. Like you mentioned, I think 2 or 3 different types of security, but it also, like I think I told you, like we use SAML Federate, as our security standard,
Mm-hmm.
and it integrates seamlessly with that, So I think that's one of the key points is that it really integrates with whatever type of security standards you have.
Yeah, absolutely. You don't, there's so many things to uh choose from. There's such a variety of things, but yeah, you don't have to use any of them. You don't have to use all of them. You can just have it integrate with what you're currently using. Yes, absolutely. Good point.
Hey, Robin. Sorry, Vinny, go ahead with your question.
And we have a much more interesting question than mine in the chat, so I'm gonna start with that one. Could you go into more into the common security features Azure provides besides DDoS?
Um, yeah, there are a lot of security features. Um, for instance, there is Azure Security Center, and that's this whole portal um, that manages your resources and monitors everything security wise. That is huge. I mean, there's so many options um, that you can configure in Azure Security Center. That's absolutely huge. So there's that. Um, there's multi-factor authentication. There are a lot of things that are beyond the scope of this presentation, like Azure Secure. I'm sorry, Azure Key Vault. Um, yeah, there are a lot of things that are kind of where we'd be getting too technical um, as far as security.
And so it is at every layer, right? I mean, to Jordan's question, it is like the raw database. Everything is fully secure. There are a lot of protocols out there that has to be passed because nobody wants to touch, the raw database. Then you have all the different code, the code base. That's a whole different security protocols. Correct, Robin?
Mhm.
And then you have all the different transmission and network connections that go back and forth. Those have blocks. So
Yeah.
like at every part of the cloud, there are security protocols attached to it, not just the front end DDoS, but DDoS is something people understand.
Mhm.
So HTTPS errors people understand, but you're saying that it's at every level. there are like hundreds of security protocols.
Yeah, it is at every level, and it's the fact that it's built in when you're building something. You go through series of processes to build it, and at any time you create something, you are also creating the security configuration. So I think that's huge because usually it's, people build something and then they worry about applying security measures later. So, other question?
And then, so my question stems from a business perspective. As say you're a business owner or higher up in an org and you're considering making the switch to cloud computing, could you give us like an example of how, like, what the savings would be there for? So say you're like, or you're a dev on the team right now and you're like, we really should move to cloud computing. Here's how much the money we would save by that. Do you have any like window into how much on average people save by doing that switch?
So there are a lot of ways to save in Azure. Let me pull up. Where is it? Okay, so they give some examples on their website. There's a company called Coverdell, and they migrated to an Azure only environment. And just by doing that, they saved $54,000 in monthly cost. And they're estimating they're going to save like $1 million over the next 2 years. That's just one example. There's so many things that are kind of enable huge cost savings. Like enterprise customers can negotiate through the contract they have with Azure. They can negotiate prices, individual prices for products that they're going to pay yearly instead of paying the public prices that web direct customers would pay. Like if I just go to the portal and I start building something, I'm paying the public prices for that. There's also enterprises can also save money by making an Azure reservation. There is, pay as you go, but companies can also make reservations of certain products. They know right off the bat, I'm definitely going to use this much, so I can, preserve, a certain quantity of compute or whatever. There are discounts that enterprise would get for doing that on top of just regular savings by converting and migrating to Azure. So there's a whole host of ways that that a company could save money, and there's a lot of programs out there for enterprise to save money. Another example is there is a program where you can bring your own license for certain products. Like if I had a bunch of VMs, I could bring my own license from on premises, and that would save a lot of money. There's a lot of different ways you can an enterprise could save money.
So to summarize what you just said, I think, Vinny, think about like having a network in tech elevator offices, right? You have a whole stack of these boxes, that blink, blue lights and green lights and red lights and yellow lights. So
Yep,
all
I've
of those
in a server room. Yep.
Yep.
Exactly
So you have a server
about.
room and you have now set that up, and you have to have a person who has to maintain that. You have to have, an actual asset, like actual cost to do it. Half of those boxes are probably not even utilized to 50%. So there's a huge capacity sitting there. And in lean terms and in accounting terms, that's a waste of space, right? Because you have space that is not being used. And this is how Amazon became Amazon, is because they found out that all their data centers was sitting at about 25% capacity. even at the fullest level of data. So they just started renting that space out. And that's what led to cloud computing. I mean, there was rack space before that, but it's that concept that you're renting out your excess capacity. And you don't need the person to maintain it. You don't need contracts, every time something fails. There are automated routines that can be set up. So I cannot even imagine in this day and age, anybody using, all on-prem computing. Can anybody think of anybody?
Maybe like the government that does something like super top secret or something like that, they might have to.
No,
but...
they're mostly AWS customers.
Are they really? Okay.
Yeah.
There are also in Azure data centers. There's special regions, special data centers that a government might use that has to be super, like, super secure, and just a different type of specialized data center for governments. So.
So my second question, completely different note for you. Thank you for answering it. So say I am a recent tech elevator grad and I saw that $200 credit. How far does that let me go play with stuff? Like, I have no concept of what it would take, how much it costs to start an Azure account or anything, like how far that $200 credit goes. But like, how far does that get me to get to start and spin up something new and play around with it to learn the tool a bit better?
Well, it depends. It depends on what you create. And it also, in most of the courses that I had taken when I was learning about this, you're going to build something and they tell you, to delete it if you're not, after the lesson. So you're not using your credits. And it also depends on how many free things you use. So, and they now have a thing called Azure Sandbox. So there are some courses that you can take through Microsoft Learn where it has a sandbox that goes with that course. And you can get in there and play with it and do everything that you want to do within that course. And they'll tell you this will be available for 4 hours or this. So a combination of, the $200 credit and then also using the sandboxes, that's even more of, it'll last, your credit will last even more with those sorts of things. But also they don't automatically charge you when your credit is done. I mean, they're not going to automatically charge your card. They'll tell you, when that happens, so you can decide if you want to have a pay-as-you-go subscription. And they do give some discounts for using Azure, but it's a lot of people have asked me, well, are they going to charge my card? I mean, they ask for your credit card, and a lot of people will ask me, are they going to charge my card without my knowledge, but that doesn't happen. They let you know far in advance when your $200 is almost up, almost used.
Awesome. So does anyone else have any other questions for Robbin over here? Going once? Going twice? Sold. You can become a Zeta Star and chat with Robbin at any time. She is available on our Slack. Also, if you'd like to connect with any of the Zeta folks that are on here on LinkedIn, I'm sure we'd all be happy to talk to you. Thank you for joining us today. Our next Lunch and Learn is going to be on June 13th, our Pride Edition one, where our co-founder over here, Rini Das, will be leading a conversation about user adoption and how to get, we all over here interact with software, tech, or design in one way, shape, or form. How do you get people to use the stuff that you do? I think that's pretty much going to be the vibe of Rini's presentation. So looking forward to that. We'll see you all on June 13th. Take care.
Thank you for coming.
Thank you.